Hello, welcome back to the physics course. Here we're going to continue reviewing essential core concepts in algebra to help us do well in physics. In this last review of the core parts of algebra, we're going to talk about exponents, we're going to talk about solving simple equations, and I'm going to review quick graphing with you just to make sure we're on the same page with all of these skills. Same thing as last time. If you watch this lesson and you're scratching your head and you're thinking, I don't get that, that makes no sense at all, then it doesn't mean that you're not smart, it just means that you need to review some algebra skills. So this is a review, but if it doesn't make sense, go back to my algebra course and work through the first part of that where we start solving equations and graphing, because I blow it up into many examples there. So the first thing we're going to do is just quickly review exponents. We use them all the time in physics. You'll find out that we use them in our problems, and we also use them in our units, like kilometers, centimeters. They all involve exponents. So we're going to use exponents all the time. So to refresh your memory, the exponent, or the number 3 raised to the exponent 2, 3 to the power of 2. What it means mathematically is we take that bottom number 3 and we multiply it by itself 2 times. This does not mean 3 times 2, it means 3 times 3. You're multiplying this times itself as many times as is specified in the exponent. And so as you know, 3 times 3 is 9. So that's what the answer is to 3 squared, it's 9. Now what if you had the number 2 raised to the power of 3? Well, what that means is you take the bottom number, multiply it by itself how many times? Well, you do it as many times as the exponent says. So 2 times 2 is 4, 4 times 2 is 8. So 2 to the power of 3 equals 8. Now the rest of these examples, I'm all gonna, the concept of an exponent can apply to any number. I can take 147 and I can raise it to the power of 4. Like 147 to the power of 4, that would be 147 times 147 times 147 times 147. I've done it 4 times because I took 147, I raised it to the power of 4. But in reality, you don't do that too much in physics. We use exponents for some things, but usually you're not doing that kind of thing too much with large numbers. But we do use powers of 10 all the time. So exponents can be applied to any number. We can use it for anything. But we have a special relationship with the powers of 10, and you'll see why as we get a little farther in the class. But if I take the number 10 and I raise it to the power of 1, what does that mean? Well, that means I take the bottom number and I multiply it by itself. Well, it's a little bit confusing because when I say multiply it by itself, you think I'm going to multiply again by 10. But what I'm trying to say is look at the pattern here. We wrote down 2 3s and multiplied them. Here we wrote down 3 2s and multiplied them. But here there's only 1, so really it's just 10. We don't write anything else down because it's already there 1 time. So 10 to the power of 1 is 10. 10 to the power of 2. That's going to be 10 times itself. So 10 times 10, that's going to be 100. Right? 10 to the power of 3, you're going to see these types of exponents all the time. It is what? Take the bottom number 10 times itself again, 3 times, again because of the exponent. 10 times 10 is 100, times 10 again makes it 1,000. 1,000. Now, these are larger and larger powers, so as I get higher and higher, notice what's happening. I went from 10 to 100 to 1,000. So every time I increase the exponent, I increased times 10 every time. That makes sense because I'm multiplying by 10 each time I go down the list. But here's the thing that blows your mind, or blows a lot of people's mind. You can actually have exponents that aren't positive numbers here. They're actually negative numbers here. All right? So if I have 10 to the power of -1, what do you think that means? Well, first you're like, well, how can I multiply 10 times